Hello, we're working on topic two, or sorry, module two, topic two, lesson five. It's called What's the Point? We're focusing on page 273 to 278, and this is writing and graphing linear equations. What I'd like for you to do on the top of this, I'm going to put the equation for slope-intercept form. We've worked on this before on guided notes, so we have some notes in our binder for this. It's the equation y equal to mx plus b, where the slope, or the m means slope, the b means y-intercept, or when we graph or look at a situation, we like to think of this as representing how much we move for the m and where we begin for the b. Okay. So we're going to write an equation for number one and number two, one with a written context and two with an equation. For number one, I'm going to write that equation, y equal to mx plus b. And we're just going to highlight some things that are important here. So it says a contestant on the game show had already won a total of $2,750 when he continued today. He earned an additional $250 for each question he answers correctly. So with this, we have to think about where we begin, how much we move. This part here is where we begin, and this part right here is how much we move. So we're just going to plug in those numbers into the equation. This is y equal to, 250x. We're saying we're getting $250 for every x. X means questions that are answered correctly, plus b, and that is 2,750. That's our initial value. That's what we begin with that day. All right, now looking at it on a graph, similarly, but the thing is here, when we rewrite this equation, we need to find what is m and what is b, and then plug that into the equation. So b is where we begin, but it's the y-intercept. It's where this line crosses the y-axis, which is right here. Okay, now what is that number? As you can see here, we're going by 10, so this is 10, 20, 30, right, that's 40. This is right in between 40 and that's probably 50, so this is 45, b equal to 45. The m, right, you find m by the slope, which is rise over run. We can see as we move vertically, vertically is going up by increments of 10, moving horizontally, right, this is a 4, so I know that this is a 2, so we can say that this is 1, and that's a 3. So every unit square going horizontally is 1. So this is going, I'm going to go down and then to the right. This is down 10, so negative 10. This is to the right, 1, 2, so it's 2. So negative 10 over 2, and if you simplify, that's negative 5. Okay, so when you plug into the equation, it's going to be y equal to negative 5x plus 45. Kind of went a little bit fast through that, but just make sure, or you kind of rewind it, pause it, come back to it, or let me know if you have any questions. Let's go to the next page, 274 for our warm-up. This is getting started. We're not going to do all of it. We're just going to do number one. We're going to skip number two. So the context here says Kelsey and Kevin are pool cleaners who must drain the community diving pools at the end of the summer. They compare the rate at which the two pools drain, right? So you have to clean these pools. For each pool, write an equation to represent the linear relationship. And then for this one, we have Cityscape Diving Pool is at a water level of 14 feet, right? So if you want to think of what's 14 feet, this classroom is about 10 feet. So 14 feet is a little bit, taller than this, or deeper than that. And drains at a rate, I'm going to put this in blue, drains at a rate of 3 feet per hour. Okay, so it's a yard. Per 1 hour, it's a yard. So where we begin, how much do we move? I think it's probably easier to, in red, where we begin, right? 14 feet is where we begin. I'm going to put 14 way over here. This is a positive 14. Drains at a rate of 3 feet. So drain, right? Is this a positive 3 or is this a negative 3? Because we're draining, we're losing water. This is a negative 3. X plus 14, right? If we had positive 3, that means we would be filling up this pool. So just be careful with your signs for that. And then this next one, might have to simplify here. Bayside diving pools is at a water level of 15 feet after 2 hours. And 12 feet after 4 hours. So a water level of 14 feet or 2 hours. Okay, so this is slightly different. We don't know where we're beginning, right? How deep is this pool? So we just have to be careful with this. We do have a rate though, right? The water level at a specific time. We're going to write a coordinate to represent each one of these. The first one is, right, the 15 and the 2. We're going to say that is 2 comma 15. The second one is 4 comma 12 because we're looking at time and then feet. And they're going to plug this into the slope formula. So we got to do some work before this. We're going to put, actually I should probably line this up vertically like this. Move this down. So we're going to do 15 minus 12. And then 2 minus 4. Okay, so 15 minus 12 is 3. 2 minus 4 is negative 2. Okay. So this is our slope. What this means, it looks like it goes down 3 feet. So down 3 feet, I could put the negative with the 3 for every 2 hours. So that's our slope, but we got to figure out what is our y-intercept. So some extra work that is involved here. So let's put slope or y equal to mx plus b. I'm going to plug in this in for m, and I'm going to take either blue or red. Let's take the red point, which is 412. This is x and this is y. So I'm going to plug in 12 in for here, and 4 in for here. Okay, so let's rewrite this. This will be 12 equal to negative 3 halves x times 4 plus b. This is also to figure out, right, how deep is this pole? Where do we begin? I had to simplify here. Let's put this over 1. We'll still keep this 12. Right, when we multiply, negative 3 times 12 is, or sorry, negative, I just said the answer. Negative 3 times 4 is negative 12. I'm going to put that here. And then 2 times 1 is 2. Right, so negative 12 divided by 2 is negative 6 plus b. And then when you solve an equation, you solve for a variable, you have to move everything away from the letter. And we do that with inverse operations. So we see that we're subtracting 6, so I'm going to add 6 to both sides. Whoops, not 16. And 12 plus 6 is 18. So this is where we begin. So I have my slope, I have my b. Let's plug that into the formula. So our equation for this is what we wanted. Y equal to negative 3 halves x plus 18, right? And what this tells me is our pool is 18 feet, and we drain this at a rate of 3 feet for every 2 hours. Or if you simplify this, this would be negative 1.5. So 1.5 feet every hour. All right, let's move on. Skipping number 2, going to our lesson here. We do have some u-dos, and the thing is we do have right, some things that we're familiar with, slope-intercept form. This is just deriving the formula, but we already talked about this as y equal to mx plus b. We're going to do a and d together. I'm going to recommend that you do b and c as a u-do. It's just saying write the equation for each linear relationship in slope-intercept form. For this, simple enough. We have everything that we need. I'm just going to do it for this one. Right, this is m, and the y-intercept, this is b right here. Right, we can just ignore that 0. So our equation for this, for number 1a, is y equal to negative 2x plus 5. Right, this is m, so I'm plugging that in for m. This is b, so I'm plugging that in for b. So that's the final equation. That's all you need to do for this problem. Right, no competition at all. For this one, it would be y equal to, instead of mx, it'll be negative 5 halves x. Instead of plus b, right, b is 3, so plus 3. That's all you gotta do for that. So give b and c a shot. Let me check it to just make sure, right, you practice it, and hopefully you're applying the correct understanding there. Let's go to the next page. Going a little bit faster. This, right, we've already done before, right? Graphing this equation, y equal to negative 2x plus 5, right? We talked about how this is where, or the b is the y-intercept, but this is where you begin. And that's where we began in this equation, right? Where 5 is on the y-axis, it's right over here. So that's where we put that point. And then for this, right, this is our slope, rise over run, but this is how much we move. So since it's negative 2, we always want a fraction. So we can put that as negative 2 over 1. That means down 2, right 1. And yeah, from this point, we go down 2 and right 1. We put a point. You can also go in the opposite direction. Instead of down 2, right 1, you could go up 2, left 1. We get other points. And it just says use the straight edge to connect and form a straight line. Okay, but that's all we're going to write on this page. So we're moving really fast. Now moving on to the next one, where we're going to do 2 examples on page 277. Yep. We're going to do A and C together. I'm going to recommend that you do B. So For this, I always recommend writing m equal 2 and b equal 2. The m for this is 5. We'll put this over 1 because that's our rise and our run. For b, it's 25. So I begin at 25. Looks like, so this is 10 right here. That means that this is 5. So this would be like 2.5, right? Because 2.5 or $2.50, $5, $7.50, and then $10. So just be careful on how we're moving for that. But just know for every 2, that's a 5. Okay, we're going to begin at 25, which is right here. Let me erase this. And to go up 2 over 1, so let's look at our x-axis. Are we going by increments of 1? If that's 4, that means that this is 2. Yep, we're going by increments of 1. Okay, so to move for up 5, right 1. So this is up 5. This is right 1, so we put a point right there. You don't need these arcs, but I'm just doing that to demonstrate here. Let's continue the pattern. Up 5, right 1. Up 5, right 1. Let's also go in the opposite direction. Down 5, left 1. It's kind of in the 0 or the O of the 20. Down 5, left 1. Down 5, left 1. I just like continuing this pattern because we can use a straight edge, but these dots are exactly on the line. Let's connect. We're going to put arrowheads on each end of the line segment. Okay. And let's do this one here. C, m equal 2, b equal 2. Remember, when we have a negative fraction, I always prefer to put the negative with the numerator, so negative 5 over positive 2. This tells me to go down 5 and right 2. And our y-intercept is positive 3. Okay, so we're going to begin with positive 3. Positive 3 is right here. And it says goes down 5, right 2. It looks like everything's going by increments of 1, so we're fine. Down 5, 1, 2, 3, 4, 5, right 2, so it should be right there. Let's continue it. 1, 2, 3, 4, 5, right 2. Let's also go in the opposite direction. Up 1, 2, 3, 4, 5, left 2. Right, should be right here next to that 8. Okay, let's connect them. We're drawing arrowheads on each endpoint. All right, now I'd like for you to now try number 2b. To give that a practice. All right, and let's finish up on this next one. We're just going to do number 3, but I'm going to ask you to do number 4 as a you do, and then check. So we're putting our understanding from getting started on writing an equation, but we also have to create the graph as well. So we're going to label the axes with appropriate variable quantities. Just note, right, x is your independent variable. Y is your dependent variable. Right, so your dependent variable depends on your independent variable, or your independent variable affects your dependent variable. So with this, it says Avery buys or wants to buy a virtual reality headset. He already has $30 saved and plans to mow lawns for $15 each to accumulate more money. Right, so y equal to mx plus b. Right, we're going to get how much we move, how much we increase is going to be $15 every lawn mowed. And where we begin is we already have $30 saved. So this is the equation that we need. So we have to figure out our variables here, right? What affects what? X always affects your Y. Do the number of lawns mowed affect how much money we're going to be able to save? Or does how much money we save affect the lawns mowed, right? It is the number of lawns mowed. Right, we live in Las Vegas, so for those of you that, I mean, we don't have too many lawns here, right? But that's just a front yard with grass, or we primarily just have rocks. And then this is total savings in dollars. Okay, now we can figure out what we want to go by for our x-axis. I'm going to say that this here is a 1. We'll have every big tick mark be in increments of 1 here. Right, so that technically means that that is a half, but no big deal there. We have to figure out, right, how much are we going to be moving? I mean, we're going to need to go 30 and then go up from there. So what do I want to go by? Let's say, let's make this, you know, let's go by 20s here. We'll say 20, whoops, 40, 60, 80, 100, and I'll have you continue from there. So really every box is going to be a 10, right? 10, 20, 30, and so on. Okay, so let's move. So for this, we're going to move, we're going to begin at positive 30 right here. And we're going to move 15 over 1. So we can add here, 30 plus 15 is 45. 45 would be at a height right there, and move over 1. So that's 1 would be right here. So this is up 15, right 1. right? To help us, we're kind of just moving up a box and a half and then over 2 boxes. So up a box and a half over 2 boxes. A box and a half over 2 boxes. Just keep continuing that. Just be careful. I think that's good enough for now. I'm a little bit picky. I'd probably just continue it, but I don't want to make those videos too long. Okay, so with this, that would be the equation and the graph for this situation. I'd like for you to try number 4, where we're talking about a golf ball number of weeks and an amount owed toward this window repayment. I'm going to recommend, I'll have you work on this, but I'll just say that this is going by increments of 2 for every big tick mark, and we'll have this go by increments of 20. But we're going to determine what goes where. This will be a negative line. And we'll stop there. We'll continue activity 2 tomorrow. All right. Let me know if you have any questions.